Hello. In lieu of having a live session on the review of the problems from the practice quiz for 14.3, I decided to attach this video to the end of the practice quiz to ensure that really only the students who are seeing this video and are doing this lesson more or less are those who have actually, tried to do the assignment, so that those who that's the best benefit, is to try it first before going over the answers. So I'm going to go through the problems that you were given, show how the answers are calculated, and then we'll go from there. So the first question you were given is that you were asked to find the lateral area and the surface area of this prism. Now for this prism here, the base, and there's one down here at the bottom as well, is this triangle. It's a triangle that's a right triangle. I could easily find the length of this other leg over here through using the Pythagorean theorem. And along with that, it says 5 there. I don't know if I might mark that just as S until I get a chance to calculate it. But the height of the prism is this 11 inches here. And the reason why I want to make sure you know what the height of the prism is, because you're going to need that for calculations. Obviously, when I find the area of the triangle, I'm going to have to be aware of a base and height as well. But since I am given that it is a right triangle, then the two legs would be a base height pairing. So me finding this other leg is not only important for me to figure out, the surface area and therefore the perimeter, of this, which help me figure out the lateral area, which would in turn help me figure out the surface area. It's also going to help me figure out the area of the base as well. So if I use the Pythagorean theorem, s squared plus 8 squared should equal 10 squared. I do the math, and s is 6 inches. So this length here is 6 inches. Please do not naturally assume that sides are congruent are congruent. These things are never drawn to scale truly. So now that I know that side, I can easily find the perimeter of the base, and I have the height. So the perimeter of the base is 24, the height is 11. 24 times 11 is 264, so 264 square inches is the lateral area. Now the surface area is just going to be the lateral area plus 2 times the area of the base. So I find the area of the base, and as I said, that this is a base height pairing for the triangle. It's not for the prism. I could treat 8 inches as the base of the triangle, the base of the base, if you will, and S as the height of the triangle. I could easily reverse that too. It doesn't matter for this right triangle. You still get the same calculation. It's just make sure you don't do that for other triangles. This works for a right triangle because I do have two sides that are perpendicular, so I can have the two legs being a base height pair. Whereas if I have other triangles, although I can let one of the sides be the base, I usually have to calculate the height using trigonometry and things like that. So, and now I know the area of the base. I have to take the lateral area plus 2 times the area of the base, and I get 312 square inches. When we deal with pyramids and its counterpart cones, we run into some other difficulties because we deal with, there's a height of the prism, of the pyramid, which doesn't get factored into a lot of calculations at this point. That it's more so with the volume that we have to worry about finding the actual height of the pyramid. But we have also a slant height of the pyramid, and then we have the edge of the pyramid. On a cone, the edge, it looks like it's the edge, and the slant height are the same. On other pyramids, that's not the case. A lot of students will mistakenly say that this 26-foot edge is actually the slant height. It isn't. The slant height is basically the height of one of these triangular faces. And the only pyramids we are going to that we are working with in this course are going to be right pyramids with regular polygons as bases. Otherwise, it gets really complicated to draw them correctly, and in some cases, you can't even draw a right pyramid with certain shapes of the base. So, when we have a regular polygon, in this case it would be a square down here, we can assume that all of these triangle faces are the same, and that they're going to be at the very least isosceles triangles. That is helpful in a couple of calculations that we have to perform later at times. So I do have to find the slant height. And the slant height, you know, if I'm basically taking this isosceles triangle and drawing an altitude of that face, which is what the slant height would be, going back to rules we learned all the way back in Unit 4, I want to say, you know, we learned that, you know, if we have an altitude of an isosceles triangle drawn to its base, then it bisects the angles, the angle at the vertex, which is not as important to me right now, but it also bisects the base. You know, I'm talking about the base of the triangle face, not, you know, not the entire base, as far as the base of the pyramid. And that's where it gets a little tricky with these things as well, because you're using the same wording to represent the different things at times. You have to make sure you're clear about what you're doing. Since I know that for this right triangle, say, right here, I have a base that's 10 inches. I have a hypotenuse that's 26 feet, or that's 10 feet, not inches. I can use the Pythagorean theorem to figure out what the slant height is. In this case, it just so happens to work out pretty nicely that I do get it to 24-foot slant height. So with the slant height in our possession now, knowing what it is, I still need to figure out the perimeter of the base, which is going to be 80 feet. I need to know the slant height, okay, because the lateral area is going to be 1/2 the perimeter of the base times the slant height. You notice I'm getting this 1/2 times, you know, dealing with a base, which is, you know, the perimeter of the base times a height, which is a slant height, very similar to the triangle formula, which kind of goes back to the first lesson that we did, that the fact that this, you know, these pyramids have, you know, overall a triangular cross sections if I'm perpendicular to the base, so it's going to have certain characteristics of triangles. The features of the square or whatever figures down here can also enter into it, but that gets to be more so when we just have to deal with finding the area of the base and things of that nature. I perform that calculation. I get 960 square feet for the lateral area. Now, as far as the surface area goes, I need to find the area of the base. So 20 times 20 is 400 square feet. And the surface area for any pyramid or cone is basically the area of the base plus the lateral area, or the lateral area plus the area of the base. So 960 plus 400 is 1,360 square feet. A lot of people try to put the 1/2 into here as well. That's not the case. You know, basically the 1/2 portion, the triangular part, was taken up in the lateral area. So you make sure you differentiate between those. A cone, very similar to the pyramid, a little easier to handle. In terms of basically, if I find this length right here, that would be the slant height. Whereas, you know, if I'm finding this on a very similar of a picture of a pyramid, that's usually going to be an edge, and I have to figure out what the slant height is. And this one here, I do have to figure out what the slant height is, because you can see that this arrow is running perpendicular to the base. This is the height of the cone. It's not the slant height. So I am going to have to figure out what that slant height is. Which I'm going to need, because just like the area or the surface area of a pyramid, the cone is very similar structure. It's going to be 1/2 the area of the base times the height. So I'm going to find the slant height. So I do realize that we're assuming this is a right regular cone. Therefore, I go from the center of the circle up to the vertex. That should be a line that's perpendicular. That is the height of the cone as well, so that should be 12 meters. And since it's intersecting at the radius, I know that this is telling me that the diameter of the circle is 8 meters, which means that the radius is 4 meters. So I use the Pythagorean theorem, and I get that the slant height is 4 times the square root of 10 meters. And I really can't simplify it much more at this point because of the fact that, square root of 10 is, not a perfect square. This would be an irrational number. So guaranteed I'm going to have decimal places. I don't want to round here, though, because, if I round at every step of the calculation, I end up causing potential rounding errors. Now, so the perimeter of the base, we call it a circumference, so that we know the circumference of the base is 8 pi meters. So when I do the lateral area, it's 1/2 the area of the base times the height, slant height. So area base, slant height, 1/2 of that. I get 16 pi square root of 10 square meters, which is about 159 square meters. Now I put an answer up there. When I do the calculation for the surface area, I am going to use this value though, because it's more precise. Using rounded values can make your answer go off a little bit again. So I do have to find the area of the base, which is just going to be finding the area of that circle. So pi times the radius squared gives me 16 pi square meters. And so I'm just going to add this and this together to get the surface area. And when I calculate that and then I round off a little bit, I get about 209 square meters. Cylinder here. Now the cylinder takes on characteristics of a prism again. It's just like a prism with a circular base. This one is not showing a marking. It should be right here. There it is. It's showing it right now. Okay. I don't know why it disappeared in the previous slide, but hey, sometimes it happens. This is telling me that we have a 6 centimeter diameter. This is the base, of course, which means that this is the height. I have some students who will mistakenly think that 6 centimeters is the height of this prism because, again, it's running vertically. It really isn't. The height of the cylinder is 14 centimeters. It's laying on its side. Just because it's laying on its side doesn't mean the height changes. So, for me to find the lateral area, I had to do the perimeter of the base, or the circumference in this case of the base, times the height, and that's going to be 6 pi centimeters times 14, which gives me about 84 pi square centimeters. In this one, I'm leaving it in terms of pi, which is okay. You didn't necessarily have to do that for excuse me, anything that you were doing on the practice quiz. Well, on the practice quiz, you were given multiple choice items, and they were in terms of pi. So, what is the surface area? Now I got to find the area of the base. So I'm just going to take half of that, the radius. So the area of the base is 9 pi square centimeters. And I'm going to add that 84 pi plus 2 times 9 pi. And you get 102 pi square centimeters. How many edges would a polyhedron have if it has 18 vertices and 12 faces? Well, any question that kind of deals with the faces, edges, and vertices is asking you to use Euler's formula, which is F plus V equaling E plus 2. And it's going to make sure I plug things in the right space. So number of faces is 12, number of vertices is 18. E is what I'm looking for, plus 2. So 30 equals E plus 2, which means 28 would be E. This thing would have 28 edges. A lot of these questions now are just asking questions about you being able to identify parts of the prism. And it's something you should always be aware of is doing before you start choosing, what your height is, how you're going to find the area of the base. So the shape of the bases they're six-sided, so they're basically regular hexagons. And of course, since it's a prism, the lateral faces should be rectangles. And that happens in all prisms. For this pyramid, what's the shape of its base? Well, the base, it's kind of getting back to this. I mean, the shape of the lateral faces, and it helps you determine the base, because the shape of the lateral faces, that should be answered first, really, are triangles. Which means the base is going to be this figure down here, which looks like and we're always assuming it's going to be irregular, it's going to be right. It's a pentagon. Excuse me. The shape of the lateral faces are going to be triangles, like all pyramids. That should not be any kind of big deal about that. If you have any further questions about this practice quiz, you can certainly contact me. If you need any help in deciding the answers or going through these and not still quite understanding, contact your teacher or me, depending on when I'm available and when you're available. But until I see you in one of my live lessons, or if you're one of my students I get to talk to on the phone, I will see you around. Have a good day, everybody.